So there were a number of questions during off hours. Some of them repeated multiple times. So we start with simple and work more complicated. Tweets per hour. That's usually pretty simple, right? Because a tweet, you press submit, and there's a timestamp. It's not like it takes 67 minutes to post a tweet, right? You just now events per year. Oh, that adds an interesting twist, right? Because the weather events is a start time and an end time. And what happens if it starts snowing on the afternoon of December 31st and ends snowing January 5th? Well, it was snowing in 2 years, right? So then it's like, okay, there was one snow event in the old year and one snow event in the new year. Of course, it doesn't snow or rain for an entire year, so that one's not too bad because it's, you're not going to have a weather event it could span towards the end of the year, new year, but it's not going to start in 1 year and go the entire year and then end the third year, right? Now we get events per hour, right? Now that becomes a bit more interesting. Now when I say hour, I don't say, oh, it starts at 12:03. No, it's 0 o'clock to 1 o'clock, from 1 o'clock to 2 o'clock, 2 o'clock to 3 o'clock, right? So there's 24 time slots. And so the complication is, well, if it starts at 1:30 and ends at 1:39, then simple, right? A slightly more complicated case, it starts at 1:30 and ends at 3:30. Well, that counts for the 1 o'clock time slot, the 2 o'clock time slot, and the 3 o'clock time slot. Even more interesting, it starts 1:30 in the afternoon on Monday and ends at 3:30 on Friday. Well, you have multiple days worth of the count, right? And so a simple, just sort of reduce how they do. And what works for the tweets is not, it needs a bit more work than to handle the years and the algorithm. Right? You have to figure out all those things. So far, so good. How many rows of data have missing data, right? Does every row in the data set contain everything? So what's missing? If the severity is missing, but you're just counting snow events, it doesn't matter, right? If start time is missing, then what do? Different story, right? So the question is, what data is actually missing? Is it missing critical data so we can't use that row or not? Hours, missing data, tweets. Well, yeah, there's a couple of fun things with fake news. How many different ways can those two words appear together? Right? Turns out that several people get different results. So like, oh, why is that? Now some other issues. You probably have your files in a directory, right? Do you really want to embed that directory name in multiple places in your notebook? Or do you want to define a string at the top that contains that directory, so when you want to read a file, it's like, oh, I'm going to read the file in this directory with that name. And that way, when someone else tries to run your notebook, right, they don't have to go and search the entire notebook to see where you hard-coded that path. Now, when you have small files, you can actually include them with the notebook and put them in the same directory. But the problem is, one of the files isn't so small. Right? Oh, let's see. What does that name tell you? Anyone? The data frame of what? Don't know, right? It's a data frame. So when people read your code and they come across DF, what's in it? How do you find out what's in it? Oh, we have to read your code to figure out what's in there, right? Now, this data science stuff is different than writing a program, right? But some of the same problems occur, and that is people want to read your notebook and understand what's going on. And so you need to help them out. And so you start picking names of your variables, you can help them out that way. And pick names that help them as opposed to making them understand the code to figure out what the names mean. Particularly since you're looking at two different data sets, right? And then they have to figure out, well, which one are you dealing with? Is it another thing is, since it's a notebook, we can actually have text fields and code fields, right? And we can use the text field to do things like, oh, I'm answering question 3. Or even better, it's like, oh, I'm answering question 3, which is how many mill events there were per hour. And my hours are labeled from, midnight to 1 is hour 0, right? You can also maybe explain your results a little bit. Oh, look, tweets per hour. Oh, is there any trend or not? Tweets per year. Is there any trend or not? Did you have to remove some rows because of missing data? Oh, maybe you should say, oh, look, there was this missing data in this column, so these rows were removed so the reader doesn't have to figure out, oh, wait, where did they do? Oh, did they move things or not move things? So it's right now you're treating it as, I have these problems to solve, I can turn them in. Because you also have to look at the point of notebooks is to do some analysis, but to explain what you're doing and explain the results. So it shouldn't just be, 5 lines of Python code and a chart. Like, oh, what would any other questions? Somehow I think students get antibodies to asking questions in class. You spend 2 hours before class and after hours answering questions, and then when class ends, it's like there's this mob, right? But well, I must admit that when I was a graduate student, there was this one instructor that taught a course to the department. It wasn't in the department only because they were shorthanded and blah. And he would do things like, he forced students to stand up to ask questions. You have to stand up, right? And then if you didn't like a question, that's a stupid question. Like, and then he couldn't understand why people wouldn't ask questions in class. Like, oh, it's a mystery, all right? So the goal of this assignment is to get you started using notebooks, start using Python, data frames. And the question about, hours, start time, and end time, part of that is like, it's not always straightforward. It's not always just, well, you just aggregate on this column and there's the answer. It's like, how do I somehow get that to count for all the hours? I mean, you haven't noticed, it's best to avoid for loops in Python. Because the interpreter language, right, and the interpreter has to then evaluate that loop every time. And when you're calling operations on a data frame, First of all, C code is compiled C code, not interpreted. Quite groups. Low blood sugar, and you're not. It's not the end of the semester when you're up 20 hours a day, right? I mean, what's going to happen when you end the semester? You're like, so last time we were looking at just things we can do with data frames, etc. And I backed up a little bit. Some helpful functions just to make a data frame we can deal with, and you just give it how many columns and rows you want, and then it fills it in with letters and numbers so you can indicate where it's coming from. And concatenate them. Why don't we have answers? That's interesting. Right, so concatenation puts them on, basically stacks them up. And then we can add, we tell which axis to add it, so we can add columns or data frames at the end of the rows instead of end of columns. Then if we, if the indices are duplicated, then we have a slight problem. Then when you try and access, well, we can ask Python to actually check, right? And tell us when the indices are overlapping. And then you can just say, I'm going to use my own and then what happens, so the first one I have columns A, B, and the second one I got columns B, C. And now when I try and combine them, what should happen? So here we're just keeping all the, and it fills in. All right, then I can start making a multidimensional in that case, if the keys do overlap, then we can so a couple tables, right, all made up. So you got one column, name of employees. And the first is what group you're in. And the second table, again, just name of the employee, and then when they started, right? Now when I combine them together, the question is, how does that work? So when we do a straight merge, you're getting the table expect, right? It contains all the employees in their group and the hire date. Does this remind you of something? Right. So it's just basically, we can think of data frames as an in-memory database, right? And then there's all these standard operations that we are nowhere useful because people have been using them for decades, right? Actually, many decades. And so now we're just recreating them without using SQL. So it's just basically SQL without SQL, right? Now if we switch them, right, so here is the group and the hire date. Well, first row is the employee. When we do it the other one, we get still first row is employee, but we get the dates first. These are fun, right? Right, so we have hire date, so it's employee, group, right? And then group and supervisor. Now we're merging those two together. And why is it one to many?
Because there could be multiple employees in
The same group. Right.
So
Yeah.
they would all have the same supervisor. So it would.
Right. So here we've got two employees of the same group. And now here again we've got many because we've got groups and skills, and a group can have multiple skills, right? And now what happens when you want to merge them together, right? Right, so we've got a group, got the skills, we merge them together. Now we're getting, Bob's in accounting, so he has so use on, so we have it, here's our group, right? And various people in the group. Got their salaries. Right. And again, the problem is that's the name, right? How do we? And so it's on the left, we're saying it's going to merge on the employee, and the right is going to be the name. Then you probably want to remove one of them, right? Because now it's repeated. Right, so you can do it on the column we want. Everyone's awake now? So we have again a function to make a data frame. What's it going to do? Well, if I'm passing in start value, right, and then you command the value for each. So I'll pass an increment, right? For each C columns, we add one, right? Ready? Right, so we got again, but it's B, C, D, A, B, C, now when you merge them on a particular column, the problem is there's two C's, right? One in each data frame. Right, so there's a C there, oops, and a C there, right? So you keep them both, but then yet you can't use the same label for them because otherwise you don't know which is which. Why the row index change from? Yeah, good question. I'm not sure. So joins, okay. So again, I'm getting my data, employees, a group. Nothing new there. Right. Employee, date hire. Merge the group data hire, left index. And so all of a sudden, right, I'm keeping the employee as an index, and I'm keeping the group at higher. And those employee is not the And a join will do the same thing. You knew it was coming, right? Just in case you're tired employees. So I got names and food they like, and then names and drinks they like. And now when you combine them, what do you do? Because the second table only has 2 people. First one has 3 people, and each table has people are not in the other one. So when you merge them together, what do you want to happen, right? Standard inner join, outer join issue. So I do a straight merge, then I only get the ones that are in common, right? And if inner is the default, outer now we get all of them, but then you have to fill in the blank spots with some value. And then of course order matters because we're doing inner joins and outer joins. And outer join one way is to flip them and get inner join. And then you can specify we're adding to the food, so we're only adding the values which exist in food. And the drink, right, you only get the and then of course, it's a standard you can flip an inner join to outer join by changing the order of the tables. So really it's just we're creating a query language for in-memory database. Right? At least the good news is your query language isn't embedded inside of a string. That you have to actually, you can't have the compiler warn you about theirs. You have to actually send it to the search engine and have it tell you, oh, I'm sorry, but this is nonsense. Yeah, so there are times you have to be careful, how's the computation being done? Is it being done in the C world or the Python world? So here we're creating, right, basically 2 series and add them together. And since there's series, that addition is being done with C code. So it's pretty fast, right? And the time it actually will does it multiple times. Right, so it did it 1,000 times just to get a good average. So here's a crazy I'm combining the 2, and then I'm as pairs, and then I'm looking at each value, and then I'm adding them together, and then combining that back again, and it was 297 milliseconds as opposed to 1. So a factor of 200, right? Which is why you don't want to use raw Python to evaluate 10 gigabyte files. Just take a lot longer than. Yeah, you be careful, right? This operation, I have my series, 2 series. I want to then find all the values greater than 0.5 one and less than 0.5 in the other, and combine them together. The equivalent to, basically doing each computation, storing the value, and then adding them together. And this causes 2 problems. One is you have to allocate the space, right? And if they're 10 gigabytes each, then all of a sudden we have to duplicate it. And that duplication, that create that space it takes time. So it's slower and it takes more space. And so there is this fancy, fun thing you can do. Here's some data for us. Just creating, 4 different data frames. Right, with 1,000 rows and 100 columns with a bunch of random numbers, right? Just make something sort of big. And then we add them all together, in Python to see what's going on, right? And it's not too bad. But using the eval, right, is a lot faster. Of course, the problem is, several things. One is now we're back into embedding our code in a string and then having someone evaluate it. And then we have to understand, since it's C code that's been compiled before we use it, there's a set of standard things it can do, right? And so there's, a standard set of operations that it does. It's a C code. So for column-wise operations, so again, here's just a bunch of random data. And so again, we are, just using standard operations, right? Or we can actually do it using eval. and we can, you know, simplify it. So it's all right. So we can. Right, so eval can access the local variables in Python. You know, so here I'm computing the mean of the data frame, and so I could just add column mean directly, or I can use eval to do it for me, right? Give it the name of the column. And the results are the same. Although we can't do direct comparison because you're talking about floating point numbers, and now we're talking about Python adding numbers versus C adding numbers and the floating point numbers. So there might be some differences. You know, so you know, Python's slow until they fix it. They do it in C, and they go all these efforts to make things work, but it's you know, we could do better these days to not have to. Again, just some random data to do various queries. And so what we're doing, I mean, this syntax starts to get bizarre, and all we do this is like, oh, give me all the, you know, everywhere where column A is less than 0.5 and column B is less than 0.5, and then combine those together, right? And the way to remember this is, understand how it works, is when we say data frame A less than 0.05, is we're getting, you know, Boolean values, true or false everywhere, and then we're adding together, and then you're just indexing, you're just getting the true values. And then, of course, we can do it in but the query will do. We can't use eval to do the same thing with a shortcut. Yeah, this details on how they actually. The data frame query uses, right? It tries to access somebody's location. If it doesn't work, then it goes to get item. Right, I mean, dropping down to C like this in a string is probably not your first approach. You want to like, okay, I need to increase the performance, so now I can. That's a standard argument, right? It's like, okay, just make your code, make sure the code is correct, right? It does what you want it to do, and once it does exactly what you want to do, and you did it in such a way people can understand it, then you can start optimizing performance. And make it less understandable or less another so doing this is you're making all these temporary copies. And so, all three of them have the same size. So if we duplicate that in the memory, so looking at population data, and these commands will actually download all the files. But it's commented out because I don't want to download the files every time I run the notebook. So reading it, the population gives the state, and then population per year, people under 18 in total. Areas gives us, right, the state, and then square areas. And then the abbreviations give the state and the abbreviation. All right, so like, okay, what's the density? Again, it's sort of standard thing with SQL, right? Once you know SQL, it's like, I get your tables and it's just, we're done, right? So I'm merging the population and abbreviations. Right. So now I get the abbreviations, population, and I'm keeping, since one had abbreviation, one had so I'm getting both, which is probably redundant. Are there any missing pieces of data? The answer is yes, population and state. Have missing data. And so now I'm looking, okay, give me everywhere that's null, and I'll look at the head just to see what's going on. And PR, any guess? Is that? Yeah, Puerto Rico. And, well, it's not a state, right? It's not clear why they don't have population and census, but and again, just looking at the state again, it's just Puerto Rico, right? Well, so here I'm looking, give me all null and give me all unique values instead of just a head. And there's one for Puerto Rico and one from USA. Like, okay, yeah, that's not a state. So, the abbreviation, but we're not going to, so we can add in the names, right? That's easy. So I've taken care of all the null values in the state table, but now we have to worry about population. We're adding the areas. Now I've got the population, we've got the areas. Oops. Again, checking for null values. Oh, and there's some null values on the area. That's going to cover those problems. Where is it? Well, it's in the United States. So if we're looking at the population density per state, then we don't care about the entire country, so we can just drop it. It's okay now. Right. So you have to look at the data and figure out, what's there, not there, what the problem is. Yes, you can just try to do computations, but then you don't know what the values mean, right? So now we can look at, just give us the year, 2010. We can get the, right, now we've got the total and the year, population, one per state. Making the state the index. And then we can just divide one column and the other column, and then we're done. And Alaska does it a lot fewer people than California. And it's also a big state, so it's like a lot of emptiness up there. Right, now we can, start doing things. We can sort it, and turns out there's a lot of empty space in California too. Particularly compared to, DC, it's just cities, right? It's one big city. And there it is, right? I've actually been in all those states, and you can believe it. It's a lot of empty space. You don't want to be in those states in the winter and your car break down. Like, out in the middle of nowhere, you die. California's 12th, right? So we can do a lot, right? I mean, once you master these things, you can start doing. Right? I mean, I think every student's had the experience of attending a class like this, and then problems. Here's how you solve the problem. Blah blah blah. Like, oh yeah, that sounds pretty good. And then, go do these 5 problems or 10 problems. You go home, and the weekend's like, huh? How do I do this? right? I mean, you've all had that, right? Because there's different type of knowledge, right? Just one type of knowledge is being able to just repeat things, but that's not really understanding it, right? Not being able to doing it. And when you do it, it's like, oh, you have to understand, I mean, that's a different thing. Not to mention the fact that instructors almost always give you the simple case, right? Well, because they're trying to illustrate, like a principle, not hide the principle in lots of details. But here's a core idea, and now you have to use that core idea and other core ideas to get it done. But you still get that panic look, right? I mean, they want me to do this? I mean, aggregation is just finding, counts and first and last and mean and median, just various. Again, just some fake data, and then we can sum it up, right? Give me the sum, give me the mean. The data frame with a bunch more fake data. Now I can say, give me the mean. I get the mean of each column, right? If you want the mean of each row, then you just transpose it and then take the mean. Or in this case, just do the columns. Right? So we can break up values and group them. We can aggregate things, or transform, or filtering it, and now we can combine results. We do a bunch of crazy things. Again, more fake data. A key column with characters, data of numbers. You can group by, but we get group by key, and then now compute the sum, right? So again, more data, key, column, data 1, data 2, again, just a bunch of random stuff. Now to point out, I do this, books do this, but we shouldn't really do it in real life. Data 1, data 2, what's the difference? And I complain about this when students do it all the time, like a string 1, string 2. I mean, the problem is there's no context here, right? It's just, here's some sample data that has no context. And I could call it foo and bar. Often I do. So here, again, we can apply just each column. And now I can ask for the min, median, and max, right? And I get each value for each column, based on the keys, right? Because remember, there was more than one A and one B, etc. And now I'm aggravating on data 1, give me the min, and data 2, give me the max, right? So we apply different functions, aggregation on each column. You can filter data. Again, sample data, standard deviation, right, on each key. Define a function. That returns when the data is, the standard deviation is greater than 4, right? So I'm filtering by which elements, right, in this column are far enough away from the standard deviation value. We can change the data, and again, the same data frame. So you're going to subtracting off the mean from each value, right? And we can use apply, get through the same data frame. So we're applying the function to, right? Anyone know what this does? Right, you were dividing. I mean, it's just a crazy C trick where instead of saying data 1 divided by this one equals, we're just saying we're going to take that column divided by that value and assign it back to where we were, right? And so there's Python's been around a long time, right? The pandas, NumPy have been around not as long as Python, but they've been around for a long time. So these libraries contain a lot of functionality that you can use to and so the question of the day is, how do you use them to compute how many snow events are in each hour, right?
What's the difference between apply and filter?
We're not filter. Give me the ones that satisfy the condition, right? Here it's just compute something and show me the result. Alright, so this is this is transform. Here we're not getting all the values, right? We're getting any other questions? So I would try and wait until the class enrollment settles down to make the class portal up, and I did that yesterday. And I forgot to add a link on the front page of the website, and I remember this afternoon, and I'm in this crazy situation where sometimes I cannot access from my office a machine on the same campus. Why? Because they now insist that you use a VPN to connect to machines from off campus, which it works fine from my home, but sometimes I don't need the VPN on campus, and sometimes I do. And the problem is sometimes the VPN doesn't work from campus. Why? I don't know. I have to talk to the tech and say, why is it when I try and use the VPN on campus, it says I can't connect? Like, when I get home tonight, I'll update the front page too. Networking is fun. That problem is not as interesting as my email won't go any farther than 300 miles problem. There was a situation where the tech guy got this, people were complaining that I sent an email, it won't go any further than 300 miles. And the tech guy goes, that's impossible. I mean, it doesn't know how far it is. And they said, look, I tried it. The guy said, look, I tried to send it to there, and there, and there, and it will go here, 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 but not there. And I tried there, and there, and there. And,
Actually, like 300 mile
radius, right.
What?
Yeah, like, wow. That was a fun problem to solve, right?
What happened?
It was a timing issue. It was timing out.
Oh, I see.
You know, some weird thing where like, oh no, it couldn't finish, and it's just too far. And then it's like, oh, so it really wasn't 300 miles. It was how many hops you're going, right? But as far as I could tell, like 300 miles. And it took the guy a long time to figure it out. But that's why they pay you the big bucks, right? To figure these crazy things out. Well, we'll stop here because I don't think it makes sense to start another